Good day, everyone. The problem given to me is this. Assuming that the vibrations of a nitrogen gas molecule are equivalent to those of a harmonic oscillator with a force constant of 2293.8 Newton per meter, what is the zero-point energy of vibration of this molecule? The effective mass of a homonuclear diatomic molecule is half its total mass, and the mass of the nitrogen here is given, which is equal to 14.0031 atomic mass units. So the given values in this question is the force constant, which is equal to 2293.8 Newton per meter, and the mass, which is the mass of one nitrogen molecule, which is equal to 14.0031 atomic mass units. It is also important to know the h bar, or the reduced Planck constant, which is equal to 1.05457 times 10 to the negative 34 joules second. The reduced Planck constant can be solved by the Planck's constant divided by 2 pi. And we are tasked to solve for the 0-point energy. So to solve for this, we can use the formula of the 0-point energy of a harmonic simulator, which is given by E sub 0 is equal to 1/2 times h bar times omega. Now, because we do not know this value of omega, we can rewrite this equation, or we can substitute omega with this equation here, therefore giving us 1/2 times h bar times the force constant over the reduced mass time raised to 1/2. And the reduced mass has its own formula, which is given by mass A times mass B all over mass A plus mass B. In this question, we are dealing with, because we are dealing with a dinitrogen molecule, mass A and mass B are just the same. So plugging in the values for mass A and mass B, you will get this, and after solving it using a calculator, you will come up with 7.00155 atomic mass units. So now that we solved for the reduced mass, we can solve for this part of the equation, where omega is equal to the square root of the force constant divided by the reduced mass. So the force constant is given here, which is 2293.8 Newton per meter. And Newton can be written as kilogram meter per second squared. So in order for the cancellation of units, we'll be using kilogram meter per second squared. And substituting the reduced mass that we solved earlier, which is 7.00155 atomic mass units. And because we want the cancellation of kilograms, we will convert the atomic mass units into kilograms, which can be achieved by converting it first into grams, since 1 gram is equal to 6.022 times 10 raised to 23 atomic mass units, or the Avogadro's number. So the units will cancel, and the grams will cancel here, kilograms will cancel, and meters will cancel. And all over raised to 1/2. Therefore giving us the final answer of 4.44172 times 10 raised to 14 per second. And since we've solved for the omega, we can go back to the original equation, where the 0-point energy is equal to 1/2 times h bar times omega. So plugging in the value 1/2 times h bar, the reduced Planck constant, which is 1.05457 times 10 raised to negative 34 joules second, times the omega, which is equal to 4.44172 times 10 raised to 14 per second. So the seconds here will cancel, therefore giving us this final answer here. The 0-point energy is equal to 2.3421 times 10 raised to negative 20 joules.